Hello everybody, welcome to week 8 of the Neon Dev Bootcamp. This is going to be a short tutorial where we're going to talk about Aave flash loans and using these flash loans to swap on Orca. And then we are going to go and talk about what's next, what you need to do to finish this bootcamp. Now let's start with Aave flash loans code. Now, if you haven't heard of it before, Aave is a protocol for lending and borrowing, and a flash loan lets you borrow assets from Aave without upfront collateral. So basically you get free money, but there is a catch. You get this free money if and only if you return the loan plus a small fee within the same transaction. So that's why we are going to build this atomic transaction to get this free money from Aave and make a swap on Orca, which is a Solana DEX. On Neon EVM, we request the flash loan. We swap assets on Solana DEX, in this case it's Orca, and we repay it atomically in the same transaction. Now, why we do this at all? Because you can get the profit of the token price by swapping on different exchanges, and on Orca the swaps are usually very, well, at least at this time, they are pretty good. And you can do this all without investing your own money. So basically you take the money from Aave flash loan and you repay it back with a fee, but you keep the difference in token prices. So here is how it works. A smart contract, which is deployed on Neon EVM, requests a flash loan from Aave. Here, for example, we request 10 USDC from Aave, which you then swap on Orca for Summer tokens, for example. And Aave sends the funds and immediately calls back a method on your contract. And inside that callback, we build and schedule Solana instructions. And in this case, it's going to be a swap instruction to swap tokens on Orca, USDC for the Summer tokens. And finally, we repay the loan plus a small fee, or otherwise the whole transaction will revert. Let's open the contracts and see what we have there. But first, you will find that, well, basically you've already worked with this repository before when you built a memecoin launchpad, but this time you're going to notice that we've updated the hard hat config so that you can use your private keys with encrypted secrets, which is a more secure way to work with them in any repository. Basically, just putting in your private keys in an env file in plain text format isn't a very secure way to work with your private keys, and this is why we've introduced this key store here. So make sure you understand how it works, go through the readme here and update it so that you can use the repository in a more secure way. The flash loan logic is handled in this contract. Let's see how it's done. First, of course, we import the Aave V3 contracts that handle the loan logic from Core V3. Then we are using our ERC24 SPL interface and the iCall Solana precompile because we are going to have a composability request to Solana. Here we derive a PDA from our Neon EVM address, which is used as a fee payer. And then this function, basically the main function here, request flash loan, asks Aave for the loan, and once granted, the execute operation gets triggered, and this is where we schedule swaps on Solana. So this is where we're going to have our composability requests. The execute operation function is automatically called by the Aave pool once the loan is issued, and basically the Aave pool is going to wait for its money back, or otherwise the transaction is going to be reverted. So first step here is a security check with this requirement. Step 2, we are going to transfer the funds to an associated token account on Solana from our PDA. And of course, to do that, we need to derive the PDA from our Neon address. And here we use the call Solana get Solana PDA method for that. Then step 3, we decode the instructions and execute them on Solana with our composability requests to call Solana precompile. And this executes 2 swap instructions on Solana, first swapping USDC to SAMO and then swapping SAMO to USDC. This basically a composability request that can target Orca, Radium, or any other composable DEX. By the way, you can also use Jupiter with Neon EVM. And then step 4, you repay the loan and the fee. Basically, you approve the repayment with the approved method, and the flash loan with the fee goes back to Aave. So to sum up, the execution flow starts when the user calls flash loan simple method and passes Solana swap instructions. Then Aave lends funds and calls execute operation method. Then the contract moves funds from the PDA to an ATA on Solana, sending them to Orca DEX to swap. And then we execute a Solana DEX swap with the execute method through our call Solana precompile. Then we approve and repay the flash loan and fee back to Aave. And this is basically how you can chain Ethereum flash loans with Solana swaps in one atomic transaction through Neon EVM. And you can use it for arbitrage, for bots, for advanced DeFi strategies, all in one ecosystem. So for this tutorial, your task will be to fork the repo and run the script to request and repay a flash loan, triggering composable Solana instructions in the process. Submit a GitHub repo with the links to BlockScout to prove that you were able to run the script. And the goal here is to understand the logic and be able to reproduce it in your future projects. For example, in your graduation project if you wish. And now let's look back at the whole tutorial and see what we've learned. We started with learning about the ERC24 SPL token, which is a hybrid token created by Neon EVM, an ERC20 interface for Solana SPL tokens that enables Solana native tokens to be accessed using Ethereum tools. Then we learned how to create a meme coin launchpad with a Radium DEX pool on Solana from EVM contracts. Then we stepped back and started looking into detail at how composability libraries created by Neon EVM ensure these composability requests from EVM contracts to Solana. And we unpacked 3 libraries: the System Program Library, SPL Token Library, and the Radium Program Library, which handle all the instructions from creating an account on Solana to initializing token mints and making transfers and swaps on Radium DEX. Then we flipped the narrative and we looked at how to create a Solana native experience for an EVM dApp with the Solana native SDK, also created by Neon EVM. And then we went ahead and integrated this Solana native SDK into a swap app using PancakeSwap contracts as the basis for the swap logic, and allowing users to connect with Solana wallets and having a Solana native experience within this EVM swap dApp. And finally, today we looked at how to request flash loans with Aave and make a swap on Orca, a Solana DEX, within the same atomic transaction. So these are the topics that we've covered so far. Next, you will have product market fit and go-to-market strategy topics covered in the next 2 videos by marketing and business experts. And what happens next is basically you have a couple of weeks more to develop the implementation project as you can see earlier, and it will run for weeks until July 16th. If you have any questions, please go ahead and ask on Discord. I'm always there to help you with anything you need. And thank you so much for your time. Goodbye.